In this program, the focus is on Deccan volcanism and large igneous provinces, Deccan traps and their geographical distribution, origin of Deccan volcanism and its significance.
Viewers, today I will talk about Deccan volcanism. Deccan volcanism, which is one of the most significant event in the geological history of the world. There are two important issues related with Deccan volcanism. That number one, it is one of the most significant volcanism across the world, and it is at the Cretaceous Tertiary boundary. What is it? Cretaceous Tertiary boundary? It is a boundary between the end of Mesozoic era and beginning of the Cenozoic era. That is marked by a boundary. In geological terms, it is known as boundary. Second important thing is that Deccan volcanism was accompanied by mass extinction of organisms. Particularly for you people, you might have heard about the sudden demise of dinosaurs. Sudden demise of dinosaurs occurred at the advent of Deccan volcanism. These are two important issues which makes this Deccan volcanism very significant. Now question arises, why we call it as Deccan volcanism? The Deccan volcanism derives its name from the Deccan Plateau in the western India that covers large part of the country, particularly in the Maharashtra region, Bombay, Maharashtra, Pune, Kolhapur, all these areas covered by Deccan hills, better known as Deccan Plateau. And this Deccan Plateau, it is a very important landform across our country. And the Deccan volcanism derives from the good development of volcanic rocks in this area. Second is, it is one of the largest igneous province across the world, better known as LIPs. LIPs, large igneous provinces. The large igneous provinces are important because they constitute major part of the crust of the earth. Now I will show you a landform which is chiefly composed of Deccan trap rocks. We better call it as Deccan traps. Why we call it as Deccan traps? Because they are in number of flows, and each flow is, they are horizontally disposed lava flows, and just like book, they are arranged in a successive manner. So there is a landform here which shows number of lava flows, and these number of lava flows you can count them visually. They are just like a pages after pages in the book. Let me introduce Deccan volcanism. Where our Deccan volcanism stands when we talk about large igneous provinces, amongst several other provinces like the Siberian traps in Siberia, the Kivanian traps in US and Deccan traps in India. This is perhaps the most interesting event in the geological history because it is at the Cretaceous Tertiary boundary. The Siberian traps and Kivanian traps and other important traps, large igneous provinces, they are not at the Cretaceous Tertiary boundary. This is very important aspect. Now I will show you a graph here where a sequence of how these large igneous provinces, they have been erupted throughout the geological time in the earth's history. If you see here, one of the oldest LIP is somewhere here in the Silurian age, and Deccan stands somewhere here, which is at the Cretaceous Tertiary boundary. Cretaceous Tertiary boundary at the end of the Cretaceous period and at the beginning of the Tertiary period. That is the beginning of Deccan volcanism in India. Now, when we define Deccan volcanism in a nutshell, it is a continental large igneous provinces. There are large igneous provinces in oceans also, but our talk is confined to those large igneous provinces which are in the continent, and that too is focused mainly on the Deccan volcanism. So, they are continental large igneous provinces occur in India, cover an area of 0.51 into 10 raised to the power 6 kilometer square. This is the spatial or geographical distribution. You can imagine how extensive this Deccan volcanism is, and it covers many provinces in the country like Maharashtra, Goa, Karnataka, Madhya Pradesh, Rajasthan, part of the Uttar Pradesh, part of the Andhra Pradesh also. It covers several provinces in our country. Another important thing about the Deccan volcanism is that the huge activity took place in a very short time span. In geological terms, the time span is 0.5 million years. That is very short time span. No other large igneous provinces in the world that has occurred in such a small time period. So, large quantity of lava erupted in a short time span, that shows how violent this eruption that has occurred in India. And secondly, as I said earlier, that it occurred at Cretaceous tertiary boundary. Now, question arises how these Deccan traps they have been originated. What is the origin? What was the energy source? What was the heat source? How they have been derived? Why they have been derived? And what is the mechanism that plays important role in the formation of such rocks in India? See here, the entire earth crust is divided into several plates, and these plates are floating over the mantle. So, Indian plate is also one of the plates which is floating over the mantle. There are two important things, one is plates, the other important thing is hot spots. Hot spots are the chimneys. Chimneys, they are very deep seated chimneys, they are connected to the mantle core boundary. You can imagine how deep they are. They are almost 2900 kilometers deep. So, they are the thermal rise or thermal diapairs, they are just in the form of diapairs. See here, I want to show you one picture here where the inner core is here, and this inner core having a outer core of the earth. The outer core is surrounded by a mantle, and mantle is surrounded by crust, thin crust, almost 34 kilometer thin crust, and this thin crust is composed of several plates which are moving over this mantle, and the heat is coming through these deep seated inner core through convection currents or advection or any other by means they are coming to the shallower depths. So, these are certain ridges where these currents are coming, they always carry along with them large amount of magma, and large amount of magma that consolidated together and form ridges. So, ridges are also there. There are hot spot and moving plates. Imagine hot spots, they are continuously emitting heat. This is the hot spot, this red color portion is hot spot, and the plate is moving over this hot spot. As a result, the volcanic activity is taking place through the fractures of the crust. Fractures of the crust are important, they facilitate the movement of the lava through those openings. This kind of mechanism is one of the most possible way of formation of volcanic rocks like Deccan traps. I am presenting a very interesting animation here. Here the movement of the plate is taking place almost 70 million years ago. Indian plate is moving and it collided with the Eurasian plate. As a result, the Himalayan mountain has formed, and still this plate is moving northwardly. Although the movement of this plate is very slow, maybe 10 centimeter per annum, but at that time the movement was little bit more faster than the present movement. So, when this plate moved over the mantle and this plate came over a hot spot, sudden eruption has taken place. But the role of Narmada Son lineament is a fracture, lineament is a weak zone, you may consider it as a weak zone or a major fracture in the earth crust. When this fracture came over the hot spot, Indian Ocean hot spot, particularly sudden eruption of lava took place, and as a result you get formation of Deccan volcanic rocks in India. But there is another theory which is also contesting with this theory, that a Shiva crater, you might have heard about the Shiva crater. Shiva crater is formed because of the meteoritic impact. The large size meteorite that fell over the crust in the western side of the Indian subcontinent, few kilometers west of Bombay, and there because of the impact the equilibrium on the mantle was disturbed, and as a result Deccan volcanism has taken place. This is another theory about the origin of Deccan volcanism. But see here, this is a 70 million years, the Indian plate was somewhere here, and over the time period it moved northwardly, and in 65 million years this plate and the portion of this plate where the Narmada Son lineament was located, it came over the hot spot and the volcanism has taken place. So, as a consequence Indian plate split from Madagascar. Earlier we were united with the Madagascar plate, Indian plate was united with Madagascar plate, and it migrated from Madagascar plate and moved in the northern direction and collided with the Eurasian plate and resulting in the formation of Himalaya. This was a major event that has taken place in the Indian subcontinent. What I am saying is solely based on geophysical data. It is not hypothetical, but it is based on geophysical data. See here, what I was speaking here, this is a Narmada Son lineament. Lineament is a major fracture here. There are 3-4 important lineaments in the Indian plate. One is Narmada Son lineament running east-west direction, the other one is Cambay lineament, the other one is here Kutch lineament. These lineaments are in the form of a rift. Rift means you have a central portion, you have a depression and you have a steep sided faults on the both sides. These fractures or lineaments, they are joined together here in this particular region. This region is known as center of gravity, where the center of gravity is very high, and this point is known as triple junction point. And Deccan volcanic activity, this is the major center of Deccan volcanic activity. It has been proved by geophysical data. This blinking blue colored circle is the center of high gravity. Why high gravity? Because high gravity rocks, basic igneous rocks, they intruded here maximum. So, this kind of mechanism was held responsible for the formation of Deccan volcanism in India, and the role of lineament is very important in order to form such a vast amount of lava flows in a very short time span. See here another animation where I have put a small fracture here, and through this fracture the sudden eruption of lava flow has taken place, and as a consequence huge lava or magma, it has came to the surface along with clouds, acid rains, and for months together there was darkness in the atmosphere, and this darkness particularly led to the sudden demise of dinosaurs. In darkness dinosaurs could not get their food and they suddenly died. That was the idea behind it. I have covered introduction and origin of the Deccan volcanism in India.
Learners, Now let us summarize what we have learned. We briefly learnt about Deccan volcanism, its spatial spread and global implications, geotectonic evolution and Deccan volcanism in the Indian subcontinent. Thank you very much.